Recover binary search tree. We are given an incorrect binary search tree where the values of exactly 2 nodes have been swapped by mistake. We know it's a mistake because all the values to the right of a node in a binary search tree must be larger, but in this case, 2 is smaller than 3. In this problem, we must recover the original tree. We will solve this in O of n time. Consider the code below. We will first perform an in-order traversal on the root node. In an in-order traversal, we first recurse on the left subtree, then we process the current node, and finally recurse on the right subtree. Note, we know the result of an in-order traversal should always be a sorted increasing list. So now we just need to find the 2 values that have been swapped in order to make the list increasing, which is the second step to solving this problem, so consider the code below. We want to iterate from the second element onwards and compare it to the previous element to make sure it's increasing. We then iterate to the next element and notice it's not increasing, so in this case we set the second value to 2 and the first value to 3, and we continue. Let's just assume hypothetically instead of a 4 it was a 0. We would notice that it's not increasing, and in this case we would only want to update second. And so we would break out of this loop and ultimately swap 3 and 0, which would give us an increasing list. Anyways, let's go back to our current scenario. It is increasing, so we don't do anything. At the end, we would have found the 2 numbers that we need to swap, which brings us to the third and final step where we need to apply the swap to the binary search tree. We follow a similar pattern to an in-order traversal where we recurse on the left subtree, process the node, and then recurse on the right subtree. But when we process the node, we check if its value equals first or second, and if so, we swap them. So in this case, when we process 3, we see that its value equals first, so we swap it with 2. And similar, when we process 2, we see that its value equals second, so we swap it with 3. And so finally, we have recovered the original binary search tree. And here's the code to do so. Please like and follow for more.